Okay, we're going to look here at adding fractions when we've got different denominators. So for example, we might have something like 1/4 and we need to add it to 3/8. Now it's not as easy as when they're the same denominator, so we have to do something first before we're ready to able to add, because we can't add with 1/4 and 1/8, they're obviously different. Again, we'll do this after we've done lots of work with looking at different pictures and really exploring it. So this is just purely abstract way of doing this after having done lots and lots of exploring with pictures and concrete. So what we need to do is get them to the stage so that they've got the same denominator, and then we use what we know about adding fractions when we've got the same denominator. So we have to see, okay, is there a number that 4 and 8 both go into? Is there a common multiple that they both go into? And it would be 8. So I always think, okay, well that's already over 8, so I'm going to keep that one as it is, and then I'm going to set this one up ready, and I'm going to make 1/4 become the same as something over 8. So I say, what have I done to 4 to get to 8? I've times it by 2. And what I do to the top, I must do, what I do to the bottom, I do to the top. So if I've times this by 2, then I must times my numerator by 2. So 1 times 2 gives me 2. So then I've got 2/8 plus 3/8. And then I'm just able to apply what I already know about when I'm adding fractions with the same denominator. So the denominator stays the same, and I just add my denominator. My denominator stays the same, and I just add my numerators. So 1/4 plus 3/8 is the same as 2/8 plus 3/8, which gives us 5/8. So we'll have a look at another example. We might have 2/5, and we're adding it to 1/10. So we know we can't add them because the denominators are different at the moment, so we need to give them the same denominator. So we think, right, is there a multiple that 5 and 10 both go into? If in doubt, you can always multiply them by each other. I could use 50, but in this case, it's not necessary because actually they both go into one of the numbers here, which is 10. So this one's nice and easy, just keep that one as it is. And this one here, I'll get that set up, and then again I say, what have I done to 5 to get to 10? I've times it by 2, and what I do to the top, I must do to the bottom. So if I've times that by 2, then I must times this by 2. So 2 times 2 gives me 4. So I know that 2 over 5 is the same as 4 over 10. And then I'm able to just add those fractions together because my denominator stays the same, as I know, and I just add my numerators, 5 over 10. Now I can simplify 5 over 10 down. I know it's the same as a half if I want to. But unless asked to, you don't always have to. It's always preferable to use the smaller numbers. Obviously the value is still the same. But keeping it like this, unless instructed to, is absolutely fine.